just thought I'd try a different intro for a change. This is just a set of tones, one on each input, routed to tracks 1 to 8 and acting as a mixer. So who needs a keyboard? And finally, this is all about recording. We've already covered most of the system. In fact, if you've got as far as the advanced mixer, you know how to get inputs to this V-track box and how to monitor them, with or without effects. So all you do now is press record.
And yet nothing changes time.
Stop when you're done. And play them back.
And yet nothing changes time.
So let's take a diversion and ask what it is we're actually recording. Now, if you're like me and come from a traditional analog tape background, it's interesting to compare the two systems. And even if you're not, it's useful to appreciate the pros and cons. Now, when you press record on an analog tape machine, the tape starts moving at a constant speed. The analog audio signal goes to the coil of an electromagnet, which is held against the tape. And because the tape is coated with a thin magnetic film, the magnet imparts a trail of magnetic variations along the length of the tape. And to play the signal back, the electromagnet works in reverse, so the trail of magnetic variations on the moving tape imparts a varying signal in the coil, which you can then amplify and listen to. On a 2-track machine, there are 2 electromagnets, so it leaves 2 trails on the tape, half the width each. 4 tracks would leave 4 trails, quarter of the width, and so on. But as the tracks get narrower, the quality gets worse. So to paraphrase a well-known film, we're going to need a bigger tape, hence the 2-inch wide tapes you may have seen, and maybe coveted like me, on 32-track studio machines. Now, the magnetic field continuously follows the signal, so the recording should be a perfect copy. In practice, there are issues such as distortion in the magnetic field, the tape hiss, and wow and flutter if the tape speed varies, and so on. Now, digital offered a wonder cure for most of these, but it brought along its own problems. And we can see them with this machine. It's already converted the smoothly changing analog audio into a stream of numbers. That's what digitizing is all about. And we've already seen this is done at these points by these analog to digital converters. Now, each number represents the voltage level of your audio signal at that moment in time. So it's a steady stream of snapshots or samples. Now, here's a simple demo of one of those tones you heard at the start, converted to digital. The waveform shows the analog input, where the voltage level varies smoothly from low to high and back again. The pairs of numbers below is the stream of snapshots of this waveform. The first number is just a sequential number to identify the snapshot. And the second is the important one. It's the snapshot value. It's a number which represents the level of the waveform at the time the snapshot was taken. So you may be able to see the numbers varying from low to high and back again in sympathy with the waveform. Now, in theory, once something is converted to numbers, everything is a piece of cake, as you can store and copy and process these with absolute perfection. But as you guessed, there's no such thing as a free lunch, and in practice there are 2 major issues. The first is, how accurately do you measure the voltage at each snapshot? Let's say you use a single digit to measure the voltage. So you can measure 1 volt, 2 volt, 3 volts, and so on. Now, what if at the time you take the snapshot, the level is 1.5 volts? You've only got 1 digit, so do you say it's 1 volt or 2 volts? Either way, you're making an approximation. Okay, let's use 2 digits then. Say 0.1, 0.2, 0.3, 1.0, 1.1, and so on. And we can now measure with an accuracy of 1/10 of a volt. So 1.5 is no problem, 1.6 no problem. you guessed it, what if the voltage is 1.54? So we need 3 digits, and this can go on forever. There's no perfect answer. Now if you don't use a high enough accuracy, the signal will sound rough or grainy.
I'll be your hurricane girl. I'll be your hurricane girl.
But the more digits you use, the more data you have to process and store. So in the end, you have to compromise and use an accuracy which is acceptable for your requirements. Now this machine has 2 options for this measurement accuracy. We've seen them before when we create songs. You might not have recognized them as they use a different term. Instead of the number of digits, it's called the bit depth. In this case it can be 16 bits or 24 bits. But it's the same idea. The more bits, the better the accuracy. And the more headroom you have before overloading, but I'll cover this later. Now just to give you a frame of reference, commercial audio CDs use this lower value, 16 bits. So when I say it's lower quality, it's still pretty good. Okay, so that's one issue. The second is, how frequently do you take these snapshots? Your audio is continuously varying. If you take one snapshot every second, you'll just get a series of clicks when you play it back. So how about 10 a second, or 100, or 1,000? Whatever you pick, there will always be a gap between snapshots where you won't know if the voltage level has changed. So just as with the accuracy issue, the more snapshots you take every second, the better the quality. But the more data you have to process and store. Another compromise. The number of snapshots or samples you take every second is called the sampling frequency. And this machine again offers 2 options for this. They're here. 44.1 kilohertz, which is 44,100 snapshots per second. And the other is 48,000 per second. The higher the number, the better the quality. And as we saw with an earlier video, this setting affects the highest audio frequency you can handle.
I'll be your hurricane girl. I'll be your hurricane girl.
Now the lower value is also used in commercial CDs, so you might ask why bother with the higher quality settings at all if your end result is going to be a CD. Well, it's useful to have quality in reserve to compensate for any losses in the system, although there can be more losses when you finally convert down to CD values. It depends how you do it, so it's not clear cut. Okay, back to our digitized inputs. We've got a stream of numbers pouring in on each of the armed tracks to this V-track box. So how do you record a stream of numbers? Well, this is exactly what a computer does when it creates a file on your hard disk, or on your memory stick or SD card. The computer doesn't really care what the numbers represent. They could be alphabetic characters for a document file. They could represent colour and brightness for an array of dots for a picture file, or, as in this case, voltage levels of a signal for an audio file. So when you press record, each track you've let through by arming it will start writing a file containing a stream of numbers to the SD card. If you've armed a stereo track, it creates 2 files, one for the left signal, one for the right. And the more tracks you arm, the more files are created, up to a maximum of 8. Now in practice, the card can only write 1 file at a time, so the machine writes a bit of each one very rapidly in sequence, and this gives the illusion it's writing to them all simultaneously. But there's a limit to how fast it can do this. And this is where the analogy with document and picture files on your computer breaks down a bit. With those, when you click save, the computer has all the time in the world to write the files. You might get impatient waiting, but the computer will take as long as it needs to ensure the file is written perfectly. and once it's done, it's finished. But in our case, the snapshots from your audio signals are continuously pouring in at many thousands of times a second. So A, the files have to be written to continuously until you stop the recording, and B, they have to keep up. If they can't keep up the pace, you'll lose some of the snapshots, and when you play it back, you'll hear glitches or clicks. Now this machine is designed to write up to 8 files simultaneously, which corresponds to 8 mono tracks, or 4 stereo tracks, or any combination. And it succeeds at doing this as long as you have the latest firmware installed. Now the type of SD card, though, is in your hands, so if you do get glitches, it's the card which cannot keep up. Now it could be faulty or incompatible, or you may be unlucky and have got a genuine fault with your machine, although these are rare. So to summarise, when you press record, one or more files will be created on the card, and these will grow in size until you press stop. And when you press play, the files are read back from the card and the streams of numbers sent along the playback path. And the files are standard WAV files, so they are compatible with computers. But if you're tempted to play them or process them on a computer, don't do it. They have meaningless names like ZZ0001, ZZ0002 and so on. And this is for good reason. These files are not meant for us humans. And that's what exporting is all about, and I'll cover this later. As we saw with the mixer videos, the signals at this point, the ones being recorded, always appear on the track meter bars. And they are only affected by the controls which come before them in the path. So that's the track effects block, but only if it's in the rec position. There's the insert EQ and the insert effects, and the source trim. Nothing else will affect the recording, not the faders and certainly not the pans. So how do you hear or monitor what you're about to record and what you're actually recording? Well, again, this has all been covered. To recap, the input signals skirt round the V-track box onto the stereo bus, whether or not you're recording, so that's one way. You can also route the inputs direct to the stereo bus, that's another way, and the send system is available on both paths, so that's another 2 ways. And any of these could be used to monitor what's going on, or for a performer's fallback system, with any of the 3 types of effects depending on the route. The track insert effect, the guitar effect, can be used either in the recording path or the playback path, depending on its position setting. If it's in the recording path, the effect will be recorded. If it's in the playback path, it won't. One thing which is different to plain mixing, when you press record, any existing recordings on other tracks will play back. You have no control over this. If the tracks are on the card and they're not armed for recording, they are automatically played back while the recording is taking place. You don't have to press play. If I press record, you can see tracks 7 and 8 are playing back. Now what you do with these playback signals is up to you. You can turn their faders down so you don't have to listen to them, but this is how you can listen to an existing recording and record another part onto another track in perfect sync. In other words, overdubbing. The signals come out here on the right of V track, so you can see why their signal levels appear on the meter bars. This is the same as if we'd pressed play, but in this case we haven't. We've only pressed record. Now there's no red box at the bottom of these meter bars, and that's because any tracks with a red box are being recorded. So these are not being played back during recording. You monitor those via this route. Now there may be input letters, like we have here, G and H, if you've assigned inputs to these tracks. But this doesn't mean the signal is coming from those inputs. they're only coming from the card in this situation. Now these playback signals are mixed with the other input signals skirting around the box, and you can route them how you like after this point. And if the track insert effect block, the guitar effect, is set to the play position as opposed to record, these combined signals can be processed by the block. In other words, you can add the effect. And note the play rec switch only defines where the block appears in the path. It doesn't matter whether the machine is playing or recording or even stopped. One other point to note is the preferences option called auto monitor. It's this one here. Now this only affects the signals skirting round the V-track box when play is pressed. It makes no difference when record is pressed. Now if auto monitor is off, which is the default, the input signals are mixed with the playback signals. If auto monitor is on, the input signals are suppressed, so you just hear the playback signals. Now this is only when you press play. Now, two common questions with SD cards are what size do I need and how fast should it be? Now we've just seen how the quality settings define the size of each snapshot or sample and how many you take every second. So we should be able to work out the size of each file on the card from these two values. Now there's one file per track, so the amount of space you need depends on how many tracks you're going to use for each song and how long the song is. So there's no definitive answer for size, as it all depends on your requirements. The best we can do is to work out how much space you need for, say, 1 minute of music using one track, and you can then multiply that figure by your particular setup. So if your song is 3 minutes and uses 4 tracks, then you'll need 3 times 4 or 12 times that figure. Now you can skip this if you like, but it's only basic sums, so let's try it. Now you've no doubt come across the word byte before, as it's used as a measurement for many household digital products. There's computer memory, hard disks, memory sticks, memory cards for a camera, even the size of disk inside your TV recorder. Now bytes are very small quantities, so you normally use a larger yardstick, such as kilobytes for thousands of bytes, megabytes for millions, or gigabytes, which are thousands of millions, and so on. So we're going to calculate how many of these are written to the card every second for each track. The first thing is to translate those bit depth numbers into bytes. These were shown when you create a song. There we are, 16 bits or 24. And it turns out that 16 bits is just 2 bytes and 24 bits is 3 bytes. Now the two quality settings on this machine allow for 4 possible combinations. So I'll just use the highest values for both, 24 bits at 48 kilohertz. And this will be the worst case scenario. So for each mono track, we have to record 48,000 snapshots every second, and each snapshot is 3 bytes. So this means that 3 times 48,000, which is 144,000 bytes, are written every second. That's 144 kilobytes per second. So this figure gives an idea of the size required and the writing speed. Note this is for a single track and it's every second. So you'll need to multiply up for more tracks and more time. And when the machine is going flat out, it's writing 8 files at once, and it's reading back 16 or 24 files, depending on your model. It can only play back tracks which are not being recorded. That's why it's 16 for a DP24 and 24 for a DP32. Now the figures may not be that accurate, as the machine may use some compression algorithms to reduce the actual number of bytes written to the card. So although the snapshot is nominally 3 bytes, that might not equate to 3 bytes on the card. And you also need more space for editing or mixing down, as well as exporting, which we'll see later, as these also create files on the card. So it's probably easiest to use the card which comes with the machine and do your own tests before committing to a larger one. Now the menu information screen shows how much space the current song is using. It also shows the two quality settings. Now this is the current song, but you don't have to load each song one at a time in order to see these values. If you go to menu, song, and press the F3 info button, you can see this last column here cycles through the values for each song. These are all the sizes. Sample rate and the bit depth. Now the size taken up by a song on the card includes all the undo information, and this depends on how many levels of undo you've set in the preferences. There it is there, undo history. You've got a choice of 1 level of undo or 10 levels. And the undo system works by not erasing files until it really has to, so it can reinstate your audio at the push of a button. Okay, that must be enough for now, so I'll cover any odds and ends in the next videos. Thanks for watching.